Hi guys, it is week 10. So we're doing 103, 104, and 105 today. So let's go ahead and get right into it. So a couple different concepts we're looking at in this lesson. Powers of negatives. Just gonna make sure I'm sharing. Okay, looks good there. So dividing terms and square roots of monomials or one term polynomials. Right, so again, they're kind of over the top with all of their parentheses and then adding the plus sign for it being plus. We know if there is no sign, it's plus. So if we go to do this in our calculator, we're going to get an error message because we're doing multiplication and addition without any numbers in between it. But we just start out, we multiply. It's all multiplication, so we can just work left to right. This gives us positive 12 times 5, which is positive 60, times negative 2, which is negative 120, times a positive 3. So just keep track of your signs. Again, if there's an even number of negative signs, like 0, 2, no negative signs, it's positive. 2 negative signs, a negative times a negative is a positive, or 4 negative signs, or 6, 8, and so on. The solution is going to be positive. If it's an odd number, like 1, 3, 5, 7, whatever, just like a negative times a positive is a negative because there's only one negative sign. Okay, so it's the same rules apply. So in this case, we had 1, 2, 3 negative signs. So that's where we got the negative solution. Positive signs don't affect anything. It's just our negative signs that we got to pay attention to. So this one, again, 3 times 4 is 12, times negative 5 is negative 60, times negative 2 is negative 120, times negative 3 is negative 360. Okay, we can apply this to exponents. So if I have, now be careful showing your calculator because you may say, oh, I put it in and it gave me a negative number. How did that work? I'll show you in just a second. So if I have example 2a, we have negative 2. Again, this parentheses helps, especially if we're putting it into our calculator, that we're squaring this, to the power of 4. It's not 2 to the power of 4 and then making it negative. It's the negative number. So it's negative 2 times negative 2 times negative 2 times negative 2. So 1, 2, 3, 4, 4 negative signs, it should be positive. So positive 4, negative 8, positive 16. Now, if we go into our calculator and try and do this, I'm going to show you, we're getting the wrong answer. That may be because we're just missing a sign. And so if I do negative, and use this negative sign down here for your negative symbol, negative 2, and I do to the power of 4, we get negative 16. But that's because what the calculator is recognizing is order of operations, 2 to the power of 4, and then making it negative. So how we avoid that is we use our parentheses. So negative 2 in the parentheses to the power of 4, and we get positive 16. So now it's computing it the way that we're intending it to. So just be aware of that. If we get like negative 5 squared, it should be positive 25. But if we do it like this and get negative 25, that's because we need to do negative 5. The power of 2 is positive 25. So just be aware of that if you're getting something in the calculator that isn't making sense, and just make sure you're putting it in correctly. B was negative 2 in the parentheses, so make sure we do that negative 2 to the power of 5. So that 5, odd number, we should get a negative answer. So in this case, it makes sense because we just did to the power of 4, which was positive 16, times another negative 2 gives us negative 32. All right, and then when we're dividing terms, we can put it out in expanded version. We can remember our rules for anything same base. So 4 over 1. Well, 4 over 1 is just 4, so that stays the same. A cubed over a to the power of 1, well, 3 minus 1 is 2, so that's where we get that, or we could think of it as we're canceling 1 out. B squared over b, 2 minus 1 is just 1. or we don't have to write it in. Or we could think of it as 1 canceling out numerator and denominator, so I'm left with 1. So let's look at, let's look at example 4. I'll get it copied down here. And we got to remember our rule of exponents and the same base. We can always start with what we know. We know how to divide our coefficients. Okay, simplify those by dividing them. Okay. And even if they're not directly over each other, like ABC and this is BAC or whatever, the rule still applies when we're simplifying. Since we're dividing everything up here by everything down here, it doesn't matter if they're directly over each other. So 10 divided by 8, well, 2 goes into both of those, so we can factor out at least a 2, so 5 over 4. A cubed, A times A times A over A, one of those are going to cancel out. We can say 3 minus 1 is 2, so 5, 4, A to the power of 2. B over B squared, well, 1 minus 2 is negative 1, or we have 1 cancel out here and 1 down here, B times B. So we're left with B down there, because B to the power of negative 1 is 1 over B to the power of 1. Then C squared over C, 2 minus 1 is 1. So I get 5A squared C over 4B. Okay. And again, we're not solving for A, B, or C. We're just reducing it and simplifying it. Okay. A lot of concepts they're covering in this one. So if we're square roots of monomials, 25x squared, well, 25 can be 5 times 5. X squared can be x times x, and then we can rewrite it as 5x times 5x. So if we're looking at these, which one of these are a perfect square? Looking at a coefficient is going to help us out. 8 is not a perfect square. 4 and 36 are. So let's keep going. X squared is x times x, so we're good so far. But y, there's no way that y times y would be y squared. So this one is not a perfect square. 36, so 6 times 6. X squared, x times x. Y to the power of 4, y squared times y squared. So that one does work out to be true. Okay, and then we can break it apart by taking the square root. So let's say we have a lot of examples in this one, but let's say we have example 6, 36x squared y to the power of 4. So taking the square root. Since these are all multiplied, if we were adding or subtracting, this rule would not apply. But we can break this apart to okay, this comes from this rule we've talked about in the past with our exponents. So we can break it apart, or we can combine them together when we're multiplying. So we can think of this as square root of 36, square root of x squared, square root of y to the power of 4, 6xy squared. Practice that problem we will do together. Lesson 104, we're looking at semicircles, arcs, and sectors. Okay, a semicircle, as we know, is a half a circle, so it's cut by a diameter, and so it's going to be half of the circle. So if we're given this shape right here, we want to find the area of this figure, and it's in meters. So we would look at this half circle with a radius of 5, so half of a circle, pi r squared. So pi 3.14 times, oh, sorry, we're finding the perimeter. So we want to find the circumference of this half circle. So 2 pi r, so 3.14 times 10, 31.4. That's the circumference if we went all the way around, but it's a half circle, so we need to divide by 2. So we divide by 2 and we get 15.7. Show you what we're doing along here. So we had pi times the diameter to give us this, and then it's a half a circle, so we divide by 2 or multiply by 1/2. That gives us this portion along the outside. Now we have to find this perimeter. Well, this is 4. This is 4 because it's square edges right here. And then if this radius is 5, then this would actually be the diameter of our circle, which would be 10, which means this would be the same thing as well. So 4 plus 4 plus 10. So 15.7 plus 4 plus 4 plus 10 gives us 33.7. Okay. This one we calculate area, so area of a circle divided by 2, area of the rectangle, and then add them together. Then we want to talk about arcs and sectors. So the arcs and the areas are the sectors. So the lengths of an arc. So if we're looking at this, we have an arc right here. It's a portion around the circle. So the circle would be all the way around would be our circumference. And then if we know this is 1/8 or 1/4 or 1/6 of a circle, we can then multiply our circumference by 1/8 or 1/6 or 1/4. Same thing with the area of our sector. We can find the area of the entire circle, and then if we know the sector is 1/3 of the circle, we can do area divided by 3. So this is 300 degrees. We want to find the area of the shaded sector. Our radius is 6. So let's find the area of the entire circle. So radius was 6. This is our shaded region. This was 300 degrees. That means this is degrees. And so area. Let's do that first. Pi r squared. Our radius was 6. So 36 times pi. This is 113.04. 113.04. And then we know 60 degrees out of 360. Well, that reduces down to 1/6 of our circle. So we can multiply this by 1/6 or divide by 6. That gives us 18.84. So that's the area of this sector, because the area of the entire thing we just found out, and this is 1/6 of the circle. So that's why we divided by 6. It was centimeters, so square centimeters. And so just one extra step. We know how to find the area of circles. We've been doing that for a really long time. Now to find area of a sector, a fraction or a portion of the circle, we just divide by whatever it is. If it's 1/6 of the circle, we divide by 6. If it's 1/3, we divide by 3, or 1/4 or 1/5 or whatever it is. So in talking about arcs, obviously, if we just say arc AB, we don't know, are we going A to B this way? Or are we going A to B this way? So we separate those into minor and major arcs. So minor arc, which we abbreviate with this little curved line above it, just like when we have a line segment, we use a straight line. Now we're using a little curve to indicate that it's an arc, A to B. And it's the minor arc. And then if we want to do the major arc, we do A, C, B, because that tells us A towards C and then towards B. So if we just say arc AB, that's a little too ambiguous. We don't know if it's the minor or the major. So we'll say minor. Major will be indicated with the 3 letters to let us know. So I'm looking at this. AOC is 70 degrees. Let's try and draw our own. Not perfectly drawn, but it'll do. 70 degrees. What is the measure of the major arc A, D, C? So the major arc A, D, C, using D for some reason. A major, so we're going A to D to C, measure of that arc. Well, all the way around is 360 degrees. So from here is going to be 360 minus 70. So that would be 290 degrees. And okay, that's all we're finding for that one. Right, example 5, a minor arc with a radius of 2, so 1, 2, centered at the origin right there, is drawn from the positive x-axis to the positive y-axis. So we have this arc here. What is the length of the arc? So the circumference would be pi times the diameter, which would be 4. And so we have 3.14 times 4, and this is 90 degrees, or 1/4 of the circle. So we're going to do 3.14 times 4 divided by 4, or 4 over 4 cancels out to be just 1. So we're left with 3.14 units is the distance from here to here. We'll go over these practice set problems together as a class. And the last one we're looking at this week is surface area of a right solid, surface area of a sphere. So this is new. We've talked about right solids, prisms, cylinders, but we haven't talked a lot about spheres to this point. So surface area, again, if we lay it out flat in a net and we add up, if there's 6 faces, we add up all 6 faces, find the area of all 6 and add them up. That's what we come up with for surface area. So for this one, the area of the triangle, 3 times 4 is 12, divided by 2 is 6. So it's going to be that same for the triangle back there. So we can multiply that by 2. This is a 5 by 6 rectangle, so that's 30. The base here would be 3 times 6, which is 18. And then the side over here to the left we can't see would be 4 times 6. So that'd be 24. So then we add up all of those and we get 84 square centimeters. It's still area, 2-dimensional, even though it's a 3-dimensional object. Surface area is still, or lateral surface area is still our units squared. So 84 square centimeters. Now lateral surface area is all the sides excluding the bases. So if you're looking at a house, for example, you want to paint the lateral surface area, the walls, you don't want to paint the outside walls and then, the roof and the basement or the foundation or whatever. You don't want to do that. That doesn't make sense. You just want to paint the exterior wall. So that would be the lateral surface area. Or of a triangular prism, it would be the area of the 3 rectangles and not the 2 triangles. So going back here, this triangular prism, it would be just these 3 sides, 18 plus 24 plus 30 to give us our lateral surface area. If we're looking at a cylinder, the easiest way, they always use the example of a soup can, and I actually appreciate it because if you were to roll out a label off of a soup can or a coffee can or whatever, it would be a rectangle. So the distance from here back around, this right here, would be the circumference of our circle. And then the height of our rectangle would be the height of the can. So if we find the circumference and multiply it by the height of our can, that's going to give us the lateral surface area. And then the total surface area, we would add the area of the circle, top and bottom. They're going to be congruent. So we would do that. So circumference, pi times diameter, we're told to use 22/7. So 22/7 times 7 times 10 gives us 22 times 10, which is 220. Okay, so this gave us the circumference, which was 22. The height was 10, which you're given right there. And that gives us 220. Now the total surface area, we got to add in these circles. So it's 7. So our radius would be 3.5. So 3.5 squared, or 7 halves, squared times 22/7. We get down here to be about 38.5 square centimeters. And then we add that back to our lateral surface area. We multiply by 2 because there's 2 circles top and bottom. So we multiply those by 2 and then add it back to our lateral surface area, and that's our total surface area. Okay. So a cube is a special rectangular prism where all the faces are the same. They're all squares. So if we know the area of one of the squares, we can just multiply it by 6. It's like a dice. If we figure out the area of one face, we can just multiply it by 6 to get that. So we've worked with rectangular prisms, cylinders, all of those things. We just did some examples of those. Now, surface area of a sphere. So thinking about, a spherical fruit or a ball or something like that. If we slice it in half, this cross section will be a circle. So the surface area of a sphere, here we get the circle formed by cutting the grapefruit in half is the cross section of the spherical grapefruit. The surface area of the entire sphere is 4 times the area of this circle. So if we cut it in half directly in the middle, like the equator, and just sliced it in half, and then we do 4 times that, that's going to give us the surface area. We'll talk about volume and how we find that down the road in a little bit. So area of a circle is pi r squared, so we just do 4 times that, 4 pi r squared. And this should be on your reference sheet. So if a tennis ball has a diameter of 6, try and make it look 3-dimensional here. Try and make it look like it's 3-dimensional. So if the diameter is 6, and then the radius is going to be 3, so we're going to do pi r squared. So diameter was 6, so just like any other circular object, we know diameter and radius are related. Diameter is always twice the radius. So there's not really a lateral surface area, it's just surface area for this because there isn't any sides, it's all rounded. So the surface area is 4 pi r squared. We're told to use 3.14. Our radius is 3 squared, so that's going to be 9, and then 4 times all of that. So we do 4 times 3.14 times 9, and we get 113.04 square centimeters. And if we wanted to round it to the nearest, this would round down to 113 square centimeters. Again, surface area, so it's still our square units. When we get to volume of a sphere, it's obviously going to be 3-dimensional, and we'll be using cubic units. Find the total surface area of this figure. It's in centimeters. Okay, so this one, if you're really good at drawing the different shapes, so it looks like 1, 2, 3, 4, 5. So it's a pentagon, even though it's not shaped like a regular pentagon. We have 5 sides, and it kind of gives this L shape right here for you to look at it 2-dimensionally. And we're looking for total surface area. I'm not going to bother trying to draw this. It'll take me forever just to draw it very poorly. So this is 4, this is 2. So we know that if we cut it in half right here, this is going to be 2 by 4. So we can do that to find the area of this section. 2 times 4 is 8. 2 times 2 is 4. 4 plus 8 is 12. So this L shape is 12. It's congruent on the back, so we can just multiply that by 2. And then this shape is 1 by 2, so 2 by, if this is 2, it's got to add up to 4, so this has got to be 2, so 1 by 2, 2 by 1 again. Okay, so 1 by 2, 2 by 1, 2 by 1. So 2, 2, 2. And then 2 by 1, 2. And then at the bottom we have 4 by 1. Okay, so do we get all 1, 2, 3, 4, 5, 6, and then 7 sides? I don't think I'm missing anything. So the 2L shapes, the 12 centimeters, we got that. It's going to be 24. Oh, the 1 by 4 in the back, I did miss that. The 1 by 4 on the bottom. And the 1 by 2 steps, we have 1, 2, 3, 4 of those. Okay, so I didn't think about this one on the back would also be 4 by 1. Again, this is where drawing it out and taking your time. This is an odd shape. We just found the surface area, or the area of this L shape. Same thing left and right. 1 by 2, 2 by 1, 1 by 2, 2 by 1. So these are all the same area, so that's why we can do 4 of those, and then 4 by 1 on the bottom and 4 by 1 on that back side that we can't see. We add them all up and it's 40 square centimeters. Okay, so that's it for this week. A lot of examples. Thank you for hanging in there. We will see you guys in class.